now we're looking at how we can do these inverse normal type computations in Excel, where if we have something like this, it's what it's actually perfectly designed for, finding the area the z-score corresponding to a cumulative area of 0.3632, where this will require the use of one of our norm dot inverse functions, where we have the norm dot s dot inv, specifically for when we're dealing with z-scores, that is the standard normal distribution. So for that, you'd put in equals norm dot s dot inv, open parenthesis, and then the area to the left. Very importantly, this only goes to the left. But once you put that in, up to rounding, you will get the desired value, where alternatively, and if we want to work with a non-standard normal, which we'll see later, we could instead use the norm.inv function. Oh, gotta put in a period, not a comma, where this requires that we put in that probability, 0.3632. Let me double check to make sure that was the number there. Yep, that's our number. And then comma the mean, which here we're doing standard normal, so 0, and the standard deviation of 1. Put that in and we get the same value of about negative 3.5. On the other hand, if we want to work with something where we're trying to find an area to the right, remember these computations are really designed to be able to handle accumulations up to, not beyond. So we have to use a little bit of finagling, a little bit of inverting here. Complementing, that's the word I'm looking for, not inverting. We're already inverting. But just to see what would happen, if we do equals norm, and I'll save space by doing s dot inv, and we put in the area of 0.0668, well, we get a z-score of negative 1.5. And looking at this, I mean, you can probably guess that that's something like what we want, but negative 1.5 is very clearly not between 1 and 2. So that should be an indication that we're going in the wrong direction. So instead what we're going to do is we're going to take that value of 0.60668 and subtract it from 1. Oh, I always forget. I have to include an equal there, otherwise it won't do math. And now we're going to do it again. Equals norm.s.inv with the area to the left of 0.9332. Can't forget that last decimal to get the same value as before. And next we're going to see how we can do this with one example for general normal distributions. I'm not going to do both of them, and I'm not going to do this stuff with the percentiles because the percentiles are exactly the same as the areas to the left, and you can see the calculator stuff for how you'd set that up anyway. It's absolutely nothing special. For this, we can use the norm.inv function, the general normal inverse, where here we want the bottom 1%, so the probability in this case is 0.01 with a mean of 179 and a standard deviation of 38.9, where if you run that, you will get our score here. It's not a z-score. I threw myself off for a second. I'm expecting z equals 88. No, it's not z equals 88. It is x equals 88.363, where I will say also that negative 2.33 is kind of an important z-score to know as well.